Okay, hello everyone. I'm going to be talking about turning compliance into an opportunity. So first of all, my name is Ken Kapur. I'm with Thermo Scientific. And so I've actually been working on compliance regulations and compliance engineering for over 25 years. Today's talk is actually going to be about European requirements, the RoHS and the REACH type requirements. So actually just a quick question, is anybody from Europe? Is anybody from Europe here? Okay, great. Anybody been to Europe? Okay, great. Got a few more folks here. I actually spent 12 years in England, and so I'm actually now here in the San Francisco Bay Area, so I'm a local. But welcome to the San Francisco area. Hopefully we'll get some nice weather this week. So I want to talk about turning compliance into an opportunity. Now, being this conference is about industrial engineering, you've got a lot of very good expertise and folks from different backgrounds, different areas tied to industrial engineering. The focus here I want to talk about was environmental and environmental compliance. One of the big challenges we have in the industrial engineering area and on the environmental compliance is there's typically a lot of focus on just components and products and development of products. Let me just get the right laser pointer. Right around here, operations and distribution. What I'm seeing from the compliance point of view and from a regulatory point of view is that there's a significant requirement to expand in the area of sourcing, looking at parts, materials, components, and where they come from, and a lot of emphasis at the end of life, and in terms of what's the impact to the environment with the activities that happen from an industrial engineering point of view or development of products. So I actually wanted to focus on several areas here in terms of environmental regulations. We've got the RoHS requirements, the REACH requirements, and the WE requirements, WEEE. So I'll be defining those in a little more detail here. Okay, so let's start with waste electronic equipment. So this is about a regulation that actually came from the European Union, started off with the European Union. But it's all about the product at the end of life. So we develop products, design products, ship them to customers. Customers use them for a number of years. And then at some point, there's an impact to the environment, right? There's an end of life of the product. And the big question is, what happens to those products at the end of life? Is it just e-waste? Is that the activity? Is it that the product's just going to be ended as e-waste? The concern from a regulatory perspective is about to minimize the environmental impact, basically manage the regulatory impact. What they talk about is taking producer responsibility. And these are requirements that Europe has defined very clearly because of shortage of land, but it's also a concern around the world. In India and many other countries, you've got the same type of activity. Limited land, you need clean water, right? So there's a concern of managing the electronics and products at the end of life. So in terms of turning compliance into an opportunity, we can spend hours actually talking about the laws and the regulations, etc. I actually wanted to jump through all that and say, well, okay, that exists. We have to be compliant. You have to meet the laws. But can you turn it into an opportunity? So one of the things we have done at Thermo Scientific is we look at the product from our customer, and instead of that product just ending up as e-waste, we say, can we take the used product and can we refurbish it? Can we resell it? Very similar to your iPhone, right? Or your smartphone. Well, you use it for a year or two, and then what happens? You throw it in the dustbin, in the trash? Hopefully not, right? Maybe you can reuse it, you can refurbish it, maybe there's a value to it. And that's what we're talking about for electronics and our products. And so it's a matter of creating those programs and being aware of the end of life and the opportunity. It's almost like reincarnation on a product. It's almost like the opportunity of that product at a later point. And so we've actually found opportunities that we have developed in our company, and I think anybody can develop, to make products available for things like a rapid exchange and a repair process, or basically just selling used products. There's emerging countries, emerging areas, BRIC countries, number of locations that may not want to buy a brand new product, may want to buy a used product. And so we've found opportunities like that where it actually increases sales, increases business. Now, where we can't actually use the product, there's actually also opportunities in the parts. So we've actually established programs and systems around the parts inside of our product. So we talk about parts harvesting, circuit boards, pumps, different drives, computers, a number of opportunities there. Not only that, we use these things like ion chips. We use these chips as part of our product and our technology when it comes to doing something like a DNA inspection. Genetic analysis, genetic sequencing. We use integrated circuit chips. We go through a lot of these circuit chips. They sell for about $300 or $400 a piece, and we go and we can go through a genome based on the sequencing on these chips. But we do go through a lot of value. So we've actually found you can take those chips and you can recycle them. With the recycler, there's gold in there. So just this year, for example, we got over $80,000 just in cash because of the recycling of the gold. So there's value here, right? There's value in electronics, value in parts, and it's worth keeping that in mind when it comes through dealing with materials and substances and products and parts. Next, I want to talk about RoHS, a restriction of hazardous substances. This is a regulatory requirement. Again, it started in Europe, but it's spread worldwide. So for restriction of hazardous substances, it actually came out, went into effect pretty much back in around 2006. So July 2006 was the RoHS directive, impacting computers, etc. And the concern was removing hazardous substances from products. So you don't want heavy metals, you don't want flame retardants that are impacting the environment. And I'll explain that in a minute, but you want to remove hazardous substances. So if you look at the timeline, right, this is about 13 years of regulatory requirements impacting anybody who makes a product. It impacts hardware products, sales of products in Europe. And it also actually impacts products that are selling in other countries. So there's a number of concerns there. So you've got the RoHS directive. RoHS comes under CE marking. If you ever look at a product and it has a CE on the back, many products have them. RoHS has come under CE marking. We've actually had to deal with this July 2014 deadline, so just recently, last few months. What we had to do is take all of our products, our genetic analysis, DNA sequencers, etc., and basically make sure they're compliant to the requirements. And a lot of it is redesign, right? It's products that have been manufacturing and selling for years and redesigning it to get the lead out, to make them compliant. And there's new requirements still coming along, IVD for in vitro diagnostic type of products, industrial products, and expansion to all electronic equipment. So a lot of concerns there about electrical equipment and impact to products that we manufacture. It's impacting all the manufacturers who want to sell products in Europe. And the same type of requirements as mentioned are happening in other countries, like China RoHS has a version, Korea RoHS, Japan RoHS, etc. And so a lot of impacts when it comes to restricted material. So if you look at different product categories, everything from household appliances to IT equipment, to electrical products, to toys, medical devices, a lot of different product categories are impacted by these regulations. In our world, we're talking about the more Category 9, which is monitoring control instruments. It was exempt before. They've expanded it. But you can see what's going on here. What they've been doing is taking the regulatory requirements and expanding them to pretty much all products. Okay. So what we've had to do is we've had to go through with quite a bit of detail, and this could actually be a very in-depth talk, but I'm going to summarize it because of a shortage of time here. But the concern is these 6 substances: lead, mercury, cadmium, hexavalent chromium, and polybrominated biphenyls, polybrominated diphenyl ethers. So items like mercury and cadmium, right? You don't want them in water. We had some discussions earlier, actually. We talked about clean water. You want your water to be clean. You don't want cadmium in your water. These types of limits are controlled very much. So when it comes to hardware products and products on the market, you want them to be free of these substances, right? So companies like ours, we've had to go through our complete product line and evaluate every single part, every single product, right down to the homogeneous level. So if you have a resistor or a capacitor and integrated circuit chip, we want to make sure that every single part is completely compliant. The only way we can be successful is actually if the rest of the industry is successful, if the rest of the supply chain is successful. So we basically need to make sure that these hazardous substances, restricted substances are removed from the industry. That's the only way we can make sure that we can be compliant. So for our products and our suppliers, obviously we go through the bill of material scrubs, and we go through part by part to check. And we've had to develop programs to be able to handle this. What about our new products? What about our existing products? OEM for original equipment manufacturer. What about products that we buy from another company and we put our name on them because of joint agreements? We need to make sure they're all compliant. So a process to do that, this is basically a five-phase process that we went through to make sure that we can go through every product, every instrument, every part. It starts with looking and understanding requirements under a gap analysis, looking at what products have to meet the regulatory dates. The bill of materials. There was some talk earlier in previous presentations about the bill of materials and looking at the BOM structure and looking at part by part. We have to go beyond that and looking at the part and looking at environmental data and looking at regulatory data and looking at substance data. We have to look at every part that impacts the environment. Is there lead? Typically you go to a company, let's say like Dell, and you buy a computer and you have the manufacturer type number. Our concern is what's inside that product we're buying. Companies like Dell are in good shape. They provide good information. But when we talk about going through hundreds of suppliers and thousands of components, it's a significant task to identify the part, determine if it's RoHS compliant, and if it's not compliant, and you find things like there's cadmium in cables or there's lead in circuit boards, it's a matter of a redesign and testing and validating. And it's very difficult when there's a number of products already on the market, but it's a matter of redesigning those and verifying that it's compliant, collecting all the paperwork and documentation to support that with test certificates and test results and test data, and putting together technical files. And in some cases, we even go through a third-party validation to make sure that it's fully compliant. But those are all the effects and efforts needed to make sure that a product is meeting the requirements to address environmental regulations like RoHS. And RoHS isn't the only one. You've also got REACH. REACH is registration, evaluation, authorization, and restriction of chemicals. What some people have done is they've talked about RoHS, and they said RoHS on steroids is basically what REACH is. It's a very extensive regulation, significant concerns about every chemical, every substance, every material that's put on the market in Europe. And this is, again, a European regulation. There's a TSCA regulation in the US, there's a China REACH, there's a number of other variations of this regulation around the world. But our concern was meeting the European regulation and the European directive. And the scope of that is what's noted here. So we've got chemicals, we've got mixtures, we've got articles. On the hardware side and from an industrial engineering perspective, our main concern is the products and the articles and making sure that those are compliant. And what is an article? A lot of debate actually among the regulatory bodies about an article, but it's basically an object which during production is given a special shape, surface, or design that determines its functions. So what that means for us is the products, like a genetic analyzer, those have to comply, and your replacement parts have to be addressed. Any packaging, we have to make sure that it meets these requirements. And the requirement is about something they call SVHCs. SVHCs are substances of very high concern. There's currently over 155 of these substances, and what they talk about is that you can't have over 0.1% of an SVHC. If you do, you have to identify it, you have to declare it, right? And then there's additional restrictions. And then the challenge with these SVHCs is every 6 months they keep adding more restrictions. So something that impacts us, something that impacts the rest of the industry. And why be concerned? One of the things out of Europe is very unique, right, is the medical system. Basically, it's a government medical system. So government's very concerned about can they do anything to impact cancer, reduce the risk of cancer? Are there carcinogens in products and parts and chemicals that have an impact? If there are, they go, let's do something about it. So that's why this list has grown, looking at things like carcinogens, or if it's mutagenic, or if there's an impact to the environment. Is it persistent, bioaccumulative, toxic for reproduction? Any impact to liver, lungs, heart, kidneys, anything that could cause cancer or have heavy metals. So a number of different criteria they went through that when it comes to an SVHCs, but these SVHCs are found everywhere. So I'm dealing with the electronics industry, I'm dealing with hardware products, but they can be used in furniture, it can be used in your cooking pans, it can be used in toys, etc. So again, from an industry point of view, it's got a very wide scope. Okay, for my purposes, I wanted to just target on what are the types of things that really impact us and really impact our products. And so we actually did a very in-depth study, did a lot of research. I have a lot more data actually that I don't have time to present today. But these are the kinds of concerns we have. So if you look at the projector, it's got a cable on it, just like your computer and your power cables. In the power cables, you might have a PVC insulation. As part of the insulation, you want flexibility. So DHP and phthalates are used in that process. And I think many of you may be aware of some of the manufacturing processes tied to that. The concern on our end is, what are those substances, what are those materials, and are they compliant to the regulatory and the legal frameworks? So we've got things like DHP. Okay, so it's a phthalate, it's used in PVC, it's used in cables, it's used in tubing. These things need to be compliant. And not only DHP, but a number of other phthalates like dibutyl phthalate, diisobutyl phthalate, etc. And they could be used in plastics, they can be used in adhesives, they can be used in paints. So a number of areas out there. And normally in the past, like I said, we'll ask for a part by manufacturer type number. We'll ask for particular specifications. So my message here is now we have to be talking about not just those specifications, but environmental specifications and regulatory specifications to make sure that it's meeting the REACH requirements, meeting the SVHC requirements. So if there are these plasticizers, and they are available in cables and plastics, which we see actually all the time, the concern is how do you get them out? Okay. And that's a challenge, I think, for everyone to identify what's restricted and then find replacements. So it's a challenge, I think, for the universities. It's a challenge for quite a few different groups. It's a challenge for students going through the university systems to understand this and learn this. For our purposes, we have to address the requirements now. So, three-step process here for the REACH and the substance of very high concern. Start with the REACH assessment. Understand the requirements. We do some benchmarking. We look for gaps. A lot of us being successful is our suppliers being successful, so a very in-depth supplier survey, collecting certificates, determining where we find SVHCs. And we've also done some things around our standardized parts catalog, which I'll talk about in a second. But the third part is really just to be compliant, right? The goal is to be fully compliant with these requirements and really eliminating the use of any SVHC, okay? So that's, again, another in-depth program, in-depth process that I could spend days talking about. I don't want to get into all that, but the focus of this presentation was, so how do we turn the compliance into an opportunity? What can we do as a company to make sure that we take these types of programs and take these types of requirements and then have a system where we can really integrate this into our business process? So what we've done is we've focused on part standardization. A company like ours, we have gone through a lot of integrations, a lot of other companies that have designed products, designed parts, designed materials that we integrate under Thermo Fisher Scientific. So we've looked at our parts and see what are the parts we're using in our database, in our system, in our inventory. What are the parts and components that's actually being used when it comes to developing new products, what we call NPIs, new product introduction. So we actually started with the angle, just from a servicing angle and a manufacturing angle. We go, okay, we got some big challenges there. We go, right now, when they're manufacturing products, it's significant challenge because of different specs, different specifications from, is it metric, is it English units, is it RoHS, is it not RoHS, what's the right tool? And we look at it from a business process perspective and just say, what's the manufacturing time needed to manufacture the product? How can you reduce that manufacturing time? What's the service time to service a product? When you send the service guy out to the field to go and service a product, how long does it take him? You know, and it's simple questions like, does he have the right tool? If he's got the right tool, it's great. If he doesn't know what tool to use, it's a problem. And so what we've had to do is standardize this. And so we took the point of view that says, can we manufacture, install, and service the product from a single toolkit? So that was kind of like the end user internally that we said. If it's easy for our folks to deal with the products and the parts, then it's going to be easy for the customer to get their product back up in operation again. So we said, let's standardize this, let's standardize our parts, let's standardize our components, and then also let's meet the environmental regulations. The WE, the RoHS, the REACH, the product safety, the certifications, all of those things, we said, let's integrate that. So normally for any program, you have to sell it. We have to sell it internally to our management and our business. And we said, you know, can we increase revenue through a program like this? You know, can we improve our margin when it comes to developing new products? And, of course, on the green requirements, can we be sustainable? So a number of different areas where there's value: usability, serviceability, interoperability, manufacturing cycle time, lower inventory levels, better quality control, as well as refurbishing and reusing products. So a lot of different aspects here that can be useful, that we set up the program, set up the guidelines, set up the catalogs, so we could identify parts and identify different areas, collaborating with teams internally. We heard about that earlier. And so working with different teams to make sure we have RoHS compliant parts, they're metric, meeting sourcing requirements, just to develop this new catalog. And we're tying into the design engineer and the CAD system they're using, like ProE and SolidWorks, and making sure there's the right training through that. So we developed our criteria: RoHS, REACH, WE, UL, eco-design, metric, serviceability, materials, finishes. And basically we went through every single part and every single category that we could do in the time frame that we had to address everything from power cords to power supplies to displays. And then we've developed a catalog that we can use for our systems. So just wanted to wrap up, last couple of slides. There's a lot of value here, I think, in looking at compliance requirements, understanding compliance requirements, tying them into the system, and also going through third-party validation when it comes to making sure that our products are energy efficient, they meet RoHS requirements. We've got third-party validation on our products. So just to summarize, in terms of the talk today, product environmental regulations is something that impacts us. The environmental regulations are pretty much impacting everybody in the world of industrial engineering. The focus is looking at it from a regulatory perspective and then a business perspective, and really tying in to turn compliance into an opportunity. And the only way to be successful is a collaborative effort. I think it was touched upon earlier at a previous talk, and you really have to collaborate with other design teams and other groups, and then, of course, stay on top of new requirements. So thank you very much. Appreciate your time. Okay, that's all I have.
Thank you. Okay. It's my pleasure to present this certificate for this talk.
Okay. Thank you very much.
Thank you.